Om Shri Sai Ram. Welcome to Sri Sathya Sai Lok Seva Gurukulam. Class 6. Today we are going to discuss about the lesson called Light, Shadows and Reflections, Part 3. Topic covered in our previous lessons: transparent, translucent, opaque objects, shadows and making of pinhole camera. Hope you remember that we have done pinhole camera as well. And light travels in straight lines. We have done this activity as well. Now, today we are going to discuss about mirrors and reflections. Hope all of you know about mirrors, because when we get ready for school, after we have a wash, we just go and adjust our hair and everything looking at mirror. What do you see in mirror? Yes, when you stand just before a mirror, you are going to see your own self, means your image. So when you are before a mirror, your reflection will come back to your eye. So we all use mirrors at home. You look into the mirror and see your own face inside the mirror. What you see is a reflection of your face in the mirror. Just now I told you. Then we also see reflections of other objects that are in front of the mirror. Naturally, if we are getting reflected in the mirror, who is standing just before the mirror, naturally all the objects that are beside us will also get reflected. Isn't it, children? Now, what is reflection? When light falls on a surface, a mirror for example, a part of it bounces off. This changes the direction of light. The bouncing off of light at a surface is called reflection. So, for example, this light is falling on this mirror and it is being reflected like this. So the light is coming onto the mirror and eye is getting this reflection. So now let us see what is the inner technology or the things that happen. See, generally if you take a plain mirror like this, so when light goes onto it, it is called incident ray. The ray of light which goes and strike the mirror is called incident ray. And when it bounces back to the other side, it is called reflected ray. So if you draw a perpendicular line, then if you calculate the angles, so the angle of incidence, see the angle that is formed with the perpendicular line with the incident ray is equal to the angle of reflection of reflected ray. Okay, children? Now, see, this is coming onto the mirror like this and the eye is getting it like this. Okay, children? Now, mirrors and reflections, activity number 7. This activity should be done at night or in a dark room. Ask one of your friends to hold a mirror in his or her hand at one corner of the room. Stand at another corner with a torch in your hand. Cover the glass of the torch with your fingers and switch it on. Like this, children. So, your friend is standing here and he is focusing the light on another friend who is holding the mirror and you are standing here. Okay. Adjust your fingers with a small gap, just like this, okay, not close, like this, with a small gap between them so that you can get a beam of light. Naturally, if fingers are apart, Generally, light passes through it in a straight line. Direct the beam of torchlight onto the mirror that your friend is holding. Do you see a patch of light on the other side? See, it's getting reflected and there is a patch on the person. Adjust the direction of the torch so that the patch of light falls on another friend standing in the room. This activity suggests that a mirror changes the direction of light that falls on it. This is the proof of incident ray and reflected ray. Okay, children. Now you understand what is incident ray and reflected ray? Yeah. Now we go to activity number 8. To show light traveling along the straight lines get reflected from a mirror. Naturally, light travels in a straight line. That's what we have learned in the previous lessons. So, that light falls on a mirror, get reflected in straight lines. Fix a comb on one side of large thermocol sheet. You know thermocol sheet? Okay, that white one. And fix a mirror on the other side as shown in figure. This is the thermocol, children, and this is the mirror. Mirror is fixed little bit cross so that in thermocol you can fix it we can just push into it and we can stick it with some Fevicol or gum. Okay, we have fixed it. Spread a dark colored sheet of paper between the mirror and the comb. See, this is the dark color sheet. This coloring what was given in the figure is indicative of dark colored sheet. Okay. Keep this in sunlight or send a beam of light from a torch through the comb. So we have kept the comb here and instead of sunlight we are just focusing with a torch in the figure. What do you observe? Do you get a pattern similar to that shown in figure 11.9? See, the light is passing through like the previous activity, the gap between the fingers. In the same way, the gap between these elements in the comb is coming straight. So the same thing, we read about shadow. See, all these pointers in the comb are opaque bodies, and because of that opaqueness we are getting straight shadows of the comb, and the light that is falling on the mirror is reflecting back in this way, okay, which forms a pattern like this. So I wish you do this simple activity at home and show to your little brothers and sisters. They feel very happy. So this activity gives us an idea of the manner in which light travels and how it gets reflected from a mirror. Children, let us make our own kaleidoscope using mirrors. See, children, this is one image of how a kaleidoscope is seen. In fact, when you look into a kaleidoscope, the inside image will be seen like this. So, by looking at this, keenly observe this, children. So, there are many things like this, many patterns, many symmetrical patterns are there. But do you think those many objects are there in this? No, there are actually few objects like colored papers or some chocolate wafer pieces or colored beads, the thermocol beads. When it reflects with the multiple mirrors, like 3 mirrors, it gives such kind of a pattern. Okay. So, what you need? 3 small mirrors that are approximately the same size, so that you need to get a perfect one. thin cardboard, overhead transparency, or plastic page protector, so that we can cover it totally. Candy sprinkles or colored paper, to get this systematic symmetrical pattern. Masking tape, naturally, you need to stick. If you want to stick anything, you need a masking tape. So children, if you closely observe this is how it is made. So there are 3 mirrors like this fixed with masking tape. Okay children, so this is how we start making the kaleidoscope. So what to do? Tape the long edges of the mirrors together so that they form a pyramid shape with the reflecting sides of the mirrors all facing inwards. So in the previous slide I have shown you how the mirrors are placed and sticked with a masking tape. So this is how. This is the mirror side inside. Okay. Yeah, you can see very clearly in that. Next, cut out a triangle of thin cardboard to fit one end of the kaleidoscope and tape it on. Just this is the cardboard piece cut in triangle and it is pasted. Use a sharp pencil to poke a hole in the center of the cardboard to serve as peephole. Just right at the center, just you make a small hole so that you can have a look at it, what is happening inside. Cut 2 triangles of transparent substance like a plastic overhead transparency to fit the other end. Yeah, because so that there should be enough of translucent light that is emitting inside. Tape up 2 of the edges to form a 3-sided envelope and put candy sprinkles or bits of colored paper or some colored thermocol beads. Tape the 3rd side closed, then use tape to attach the envelope to the end of the kaleidoscope. Just like this. You can see one more object like this. Now look through the end that has the peephole and aim the kaleidoscope at a light source. The colored objects on the other end will reflect off the mirrors into star-shaped patterns. I have shown you the patterns. So you have to do this kaleidoscope. And show it to your friends and your brothers and sisters so that you can have a fantastic scientific self-made toy. Okay, and you can always give as gift to others as well. Do you know mirrors were originally invented over 200 years ago in Germany? Created by a chemist Justus von Liebig in 1835. He discovered that if you apply a thin layer of metallic silver to clear glass, you can create the reflective surface, the mirror. The first forms of mirrors appeared in the ancient times when they would simply use a pool of dark water or dark container filled with water. This is only changed in around 6000 BCE when polished glass began to be used. Mirrors can reflect sound waves and they are known as acoustic mirrors. Mirrors were used in the Second World War in detecting sounds coming from enemy aircraft. The belief that breaking a mirror will bring you 7 years of bad luck originated from Roman times, when the Romans believed that by breaking an old mirror, you also break your soul. Today, this is still a common belief among most individuals. Yeah, naturally, there are many beliefs. They have their own reason, and each area will have their own belief system. So, each one will have his own belief. Are you able to explain these keywords from this chapter? Like luminous? Can you remember? Yeah. Luminous, that which emits light is luminous. For example, sun is one luminous object. Then what is mirror? Just now we have gone through that lesson. That which reflects the image that stands before a mirror is called mirror. Then opaque bodies are those which never allow light pass through them. Pinhole camera, you have done an experiment also, the activity also, with 2 cardboards. Do you remember? So pinhole camera is the one which works on a pinhole that is made on a cardboard and adjusted to get the shadow reflected on the screen which we allow. Reflection, just now we have gone through this. Reflection is something like this. The light that falls on an object or a mirror reflects, bounces back. That is reflection. Shadow. Once again, if there is every opaque body, when light falls on every opaque body, a shadow is formed the other side of the opaque body. Translucent. Do you remember? Translucent is a body through which light passes, but partially. Transparent. Transparent is something like plain glass. Transparent bodies are the bodies which allow light pass through very clearly 100%. Okay, children? So, let's have the summary of the lesson. Opaque objects do not allow light to pass through, isn't it? Yes. Transparent objects allow light to pass through them, and we can see through these objects very clearly, isn't it? Translucent objects allow light to pass through them partially. Okay, children? Let's have some more. When an opaque object comes in the path of the light, a shadow is formed. Isn't it, children? Just now I told you. Pinhole camera can be made with simple materials and can be used to image the sun and brightly lit objects. Light travels in straight line. We have done an experiment activity as well. Mirror reflection gives clear images, isn't it? When you look at mirror to dress yourself, to groom yourself, it gives a clear picture of yours, clear image of yours. Then only you will be able to groom yourself, right? Now we have come to the end. Who are you really when you look into a mirror? Let's ponder over this statement by Swami. Generally, children, when you look into a mirror, the mirror will show what is coming out of yourself. Understand? If your face is smiling, it shows a smiling image. If you are crying, It shows a crying image. So children, you always need to have love in your heart. That should reflect on your face. When love is reflecting from your face, and all the people around you will also start emitting love, giving love. And when everywhere love fills, that means it is heaven. Children, love is God. Live in love. And light is God. Thank you. Sai Ram.